Hi folks, welcome to the 3.2 video on independent and mutually exclusive events. And so in section 3.2 in your textbook, we're looking at two main ideas. The first one is independent events, and the second one is mutually exclusive events, okay? And so we're gonna do a couple of examples, but also use this as a chance to kind of talk over the big picture concept. So an independent event, that's going to be the example that we look at first, okay? An independent event is independent events are basically events that have nothing to do with each other. So like the outcome of one event has no bearings on the outcome of another event, okay? So for example, let's say you take a lift home, okay? So taking a lift home, and another event might be doing your laundry. Like whether you take a lift home or not, or whether you do your laundry or not, those two have nothing to do with each other, right? Or it could be, one event could be buying a lottery ticket and the other event could be finding a penny on the floor, right? Those two have nothing to do with each other. And so we call those independent events. Okay. And so one of the classic examples of independent events is when we're looking at a deck of cards and we're sort of pulling cards from the deck. Okay. So let's say that we have a fair, well shuffled deck of 52 cards. All right. So every deck of cards is going to have 52 cards. And in those 52 cards, there are 4 different shapes, or we call them suits, okay? So there's the clubs, the diamonds, the hearts, and the spades. And each of those has 13 cards. So in the diamonds, there's 13 diamonds, and they're 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, and King. All right. And sometimes that one, we also call it an ace, but there are 13 cards that are diamonds. There's 13 cards that are hearts, 13 that are spades, and 13 that are clubs. Okay. Now we're looking at an event where we're picking 3 cards at random. Okay. So we have this deck and we're just going to pick 3 cards and see what we get. So part A says, suppose that you know the picked cards are a queen of spades, a king of hearts, and a queen of spades. Can you decide if the sampling was with or without replacement? Okay, so with replacement means like we picked a card, we looked at it, and then we put it back. We picked another card, we looked at it, and then we put it back. But the without replacement means we would like pick a card, put it off to the side, and now it's no longer in the deck. Okay, so then we pick another card, we look at it, we put that one off to the side. And so as we pick, there's sort of fewer cards to pick from. Okay, but let's take a look at this again. So we've got a queen of spades. So we picked a queen of spades. We pick a king of hearts. And then we pick a queen of spades. Now, there's only one queen of spades in the deck, right? So that means if you take a queen of spades out and you leave it out, you can't ever pick it again because it's not in the deck anymore, okay? So in this case, we have a with replacement, all right? Because we looked at the queen of spades, we looked at it, and then we put it back in the deck and just happened to pick it again, all right? That's what we mean by when we say with replacement. When we're talking about without replacement, okay, let's see, that means that we maybe can never pick that one again, okay? So let's take a look at B. Suppose you know that the picked cards are a queen of spades, a king of hearts, and a jack of spades. Can you decide if the sampling was with or without replacement? And so queen of spades, king of hearts, jack of spades. There's no repeat cards. So possibly that means that we pick them and then we never put them back, okay, without replacement. However, maybe we just never picked the king of hearts again. Like maybe we pulled out a king of hearts and then we put it back in and then we just happened to not pick it. So it's also possible that it was without replacement, okay? And so in this case, we cannot tell whether it's with or without replacement, okay? It possibly could be we put them back in and we just never picked them again, okay? And so this idea of with or without replacement is important as we move on in this chapter, and we're going to think about things like probability, okay? The second main idea in this section is something called mutually exclusive events, okay? And so we're going to build on what we talked about in 3.1 with the sample space and use that to help us find the probability of different events, okay? So we've got a box with two balls. One is white and one is red, okay? And so if I think about this, I've got a box and I've got two balls. One is white and then the other one is red, okay? And so we select one ball, we put it back in the box and we select a second ball. This is what we mean when we say sampling with replacement. Like we take it out, we look at it, and then we put it back in, okay? So let's find the probability of the following events. So part A, let F equal the event of getting the white ball twice, all right? So before I start, what I'm going to do is I'm going to go ahead and write my sample space, all right? In fact, I'm going to do it here, my sample space, okay? And so what I mean by sample space is like, what can I pull out of the box? So I've got a white ball, and then I could pick a white ball, or I could pick a white ball and then a red ball. Or I could pick a red ball first and then a white ball. Or maybe I pick and both times I get a red ball out, okay? So how many things are there in our sample space? Well, there are 4 things in our sample space. All right, so back to A. Let F equal the event of getting the white ball twice. So in my sample space of 4 things, only one of the times do I get a white ball twice, okay? What that means is that the probability of F is 1 in 4, or we might say 0.025, okay? All right, let's take a look at B. It says, let G equal the event of getting 2 balls of different color. That means we can't get white, white, and we can't get red, red, but we could get white and then red, or red and then white, okay? So of these 4, these 2 satisfy G. They are the event getting 2 balls of different colors. So our probability of getting G is 2 in 4, or we could say 0.5. All right, C, let H equal the event of getting white on the first pick. Okay, so what's my probability of getting white on the first pick? Well, this one, white, white, or this one, white, red. Those both satisfy. So that is 2 out of the 4. So we've got 2 over 4, which equals 0.5. All right, so hopefully that was a nice review on that probability like we did in that 3.1 video. But now let's talk about this idea of mutually exclusive, okay? And so it turns out that when we're looking at things that are mutually exclusive, all right, so let me write this down. Mutually exclusive, it means that the probability of getting something and something else is 0. All right, it means they can never happen at the same time. Okay, so let's take a look at question D. It says, are F and G mutually exclusive? So in other words, can I get the white ball twice and get 2 balls of different colors? Well, let's think about that. If I'm getting the white ball twice, I'm getting 2 of the same color. I'm not getting different colors. So in this case, the probability of F and G is 0. So yes, they are mutually exclusive events. I can't pick a white ball twice and then get 2 balls of different colors at the same time, okay? So let's try that kind of reasoning again for E. Are G and H mutually exclusive? So G is the event of getting two balls of different colors, and H is getting white on the first pick. Well, if I look at my four things in the sample space, I can get white on the first pick and get two balls of different colors. In fact, that happens 1 out of the 4 times. So my probability of getting G and H is 1 out of 4. This is not 0, so they are not mutually exclusive. Okay. In other words, I can have a white ball come out first and end up with two different colors. They are not mutually exclusive. Okay, so that's the theme for 3.2. We're going to take a look at independent and mutually exclusive events in a lot of different ways. Okay.